Today I am going to talk about scalar triple product, all about scalar triple product, and try to give one or two examples. And first of all, we have the three vectors, vector A, vector B, and vector C. These are the three vectors. And suppose I first find out A cross B, that is the vector product of A and B. And in second step, I find out A cross B dot C, that is the dot product. First I find out A cross B, after that I find out dot product with C. Now this result of A cross B dot C is called as a box product, also called as a mixed product, also called as a scalar triple product. And this scalar triple product can be written inside square bracket like this. Here vector A and vector B and vector C. Some books write even comma there, and some books write without comma like this, just A, B, C inside square bracket. And if you are not using the square bracket, then you simply write A cross B dot C. But to write such a lengthy, we can avoid, just write this in square bracket A, B, C, either with comma or without comma. Both are valid. Most of the books, they don't write comma here, but some teacher even use the commas. For example, here we have the three vectors, and we will understand how to find out box product. Vector A, vector B, and vector C are given, and we will find out box product, or it is a scalar triple product. So solution. This is a very basic method I am going to do here, and one more shortcut method even there, so that I will be teaching you in part 2. So in step 1, we first find out A cross B by using determinant method. So we get A cross B equals to minus 5i and plus 4j and minus k. Now in step 2, A cross B and dot C, that is result of A cross B 5i plus 4j minus k dot C, C nothing but 3i plus 2j plus 4k. Now this result is nothing but given by product of A1 B1 plus A2 B2 plus A3 B3. So A1 minus 5, B1 is 3, and A2 is 4, and B2 is 2, A3 is minus 1, and B3 is 4. This result equals to minus 15 plus 8 minus 4. That is minus 15 plus 4 equals to minus 11. Therefore, the triple product of ABC is equals to minus 11. Now, what is the meaning of this box product? So meaning of scalar triple product or meaning of box product. For that, we are going to consider a parallelepiped. What is a parallelepiped? It is a three-dimensional shape. That means if you just extend the cube, you will get a parallelepiped. And it is having 6 phases. And every phase is a parallelogram. Therefore, it is called parallelepiped. Now, with the help of this parallelepiped, let us understand the meaning of box product. Now in this parallelepiped, there are the three edges OA, OB and OC. They are called coterminous edges OA, OB and OC. We take O as the origin. And now we represent OA by vector A and OB we represent by vector B and OC we represent by vector C. So we got three vectors here, vector A, vector B and vector C. Now we have the two vectors, vector OA and vector OB. Vector OA represented by small vector A, that is the vector A, and vector OB equals to vector B. To find out the area of parallelogram OADB, we first find out A cross B. So A cross B gives area of parallelogram OADB. We know that whenever there are the two vectors, vector A and vector B, if you find their cross product, the cross product is perpendicular to the plane formed by both the vectors vector A and vector B. Therefore, here in diagram, the ON, the vector ON, this is perpendicular to plane, this plane, perpendicular to this plane, that is shaded region. So it is perpendicular to plane formed by vector A as well as a vector B, and so vector N is nothing but A cross B, and let us say it is making an angle theta with vector C. So this result, that is a cross B and dot product with the C, that is the C. This result will give us the entire volume of this parallelepiped. So A cross B dot C represents numerically volume of the parallelepiped, and vector A, vector B and vector C must be coterminous edges, then only we'll get the volume.